All right, this is how we find exact trig values of special angles. And the first method I'm going to use is one I think that Khan Academy goes over quite a bit, which uses the unit circle. The thing about the unit circle you want to remember is that it is centered on the origin. Okay, so let me make sure I've got a line here. And you're working with the same coordinate axis, the XY axis. Will help kind of your senses about you when it comes to all these coordinates around the circle at these different angles. This particular unit circle has both degrees and radians label all the way around in the positive direction. So you look at a question, somebody sent me this one here. Find the following trigonometric values and express your answers exactly. The thing about the unit circle that's nice is if you have it in front of you or you can remember it all and regenerate it when you need it, then it's like a map. And all you need with a map is to know kind of the legend to the map, what the symbols and the scale is. So in the unit circle, the x coordinates, okay, let me see here. Should have a blue pen going. Give me one sec. Okay, there we go. So the x coordinates at each of these angle locations is going to be the value you get when you take the cosine of that angle. Hold on a second. You know the angle you're looking for. Here it's 5 pi thirds. If you're looking for the cosine value at that angle, first you got to find the angle. So 5 pi thirds, 5 thirds of anything is more than one of it. So here's 1 pi. So if you were just going to 1 pi, you'd stop right there. It's the straight angle. But we're going to 5 pi thirds, right? It's kind of hard to read. Let's superimpose this. All right, so there's pi. And if I cut that into thirds, it's 1/3, 2/3, 3/3 pi. That's not enough. I need 5/3 pi. Ooh, that's kind of wonky. Hold on. There's my undo button. Hang on a second. So we draw another pi so we can build more thirds of pi. So we stopped at 3/3 pi, 1 pi, 4/3 pi, 5/3 pi, 6/3 pi. So here's the angle. 5/3 pi means we're going to go all the way into the fourth quadrant and look at this set of coordinates right here. So this is an x and a y. And the legend of the map says cosine takes us to the x coordinate. This is great. If you've done all the work of memorizing this or finding it accurately, then you just take that is the x value, and that is your exact cosine ratio for that angle. Boom, done. Now, if you're looking for the sine, we'll switch colors here. The rest of the legend says sine is simply the y value at that same location. So 5/3 pi, same time. Let's go grab the y value, in this case negative √3/2. Okay, so that's that. Let's go to the next page. I've got a couple other examples, and we'll use the unit circle again. Okay, so this time, different angle, and I threw a tangent in there. Let's see what's going on now. So for starters, we're going to take the sine of 2 pi thirds. Next, we'll take the tangent of 2 pi thirds. So we have to find where's 2 pi thirds. Excuse me. So first, draw a nice, easy to read straight angle, because we know that's 1 pi. The thing about 1 pi that's easy to do is you can cut it up into any fraction. So thirds of pi, you're going to take 3 equal chunks to pi. So 1/3 pi, 2/3 pi, 3/3 pi. So you can see it's sitting right there. Again, if you're what I call a unit circlean, you memorize this unit circle and you pull it out and regenerate it every time you need it. Okay, so same legend to the map exists every time you pull this out. For the sine of an angle, all we need to do for that angle is find, this is theta by the way, is find the y value of that coordinate. So here I can see the y value is root 3 over 2. Your opposite over hypotenuse of 2 pi thirds radians. Now tangent, I don't know if this has come up in the Khan Academy assignments, but the legend of the map here doesn't only apply to sine and cosine. I'll write cosine down here. Cosine of an angle, like the last, just the x coordinate. So if you kind of run this out for tangent, what it would be is the y value over the x value. Okay. So in this case, we have a little bit of reducing to do. And so I use both my x and my y. So that's root 3 over 2. Here's your y value. Over your x value of negative 1/2. Again, this is second quadrant over here. You know, yeah, x and y quadrant. X and y putting us in quadrant 2 means we're going to have a negative x value and a positive y value. Do not leave your answer in such a layered fraction looking thing. Go ahead and work that out. It's just really a fraction of 3 over 2 divided by negative half. Remember, dividing fractions by fractions, you're going to flip and multiply that second fraction. So that'll be negative 2 over 1. Okay, so 2 upstairs and down, but we have a negative that's going to hang around here. So you're going to end with a negative rad 3 ratio, which we'll just say 3. So, and for the end of pi thirds, technically it's negative root 3 over 1, but it's nice to clean that up when it's got a denominator of 1. All right, a couple more examples. I have another method, and this is actually my favorite method. If you don't think of yourself as a unit Circlean, you might gravitate towards this one. And the reason, you know, I know I'm a few minutes into this video, but the reason I'm going to share this one is because you really don't have to memorize that much. If you can remember your 2 special right triangles, 30, 60, 90, 45, 45, 90, and kind of adjust those into radians. So, you know, 45, 45, 90 would be pi quarters instead of 45 degrees. And a 30-degree angle is a pi sixths radian, and a 60-degree angle would be pi thirds, all right? Besides that, all you need to know is which quadrant is which, you know? So quadrant 1, I know that's, hang on, that is ridiculous. This stylus, hold on here. Quadrant 1, quadrant 2, and how the x, y values change signs from quadrant to quadrant. That, you know, that's news to us. We know that x's are positive on the right, y's are positive up above, and then we go negative x values on the left and negative y values down below. So here's what we're going to do. This is the same exact problem we did a minute ago. Cosine of 5 pi thirds. Okay. Step 1, locate the angle. Okay. Just use a symbol there. So what we're talking about is this is thirds of pi. Okay. So thirds of pi. So I'm going to lay one straight angle, pi, if you will. So pi radians gets me the straight angle. And then I'm going to mark it into thirds. So 1/3 pi, 2/3 pi, 3/3 pi. I know I just found this one a minute ago, so some of you are like, why are you talking through this again? Well, pretend you just walked up to this and you didn't want to regenerate the whole unit circle for 1 or 2 little problems. Here's how you go about it. I need, though, okay, so step 1, locate the angle. What I'm doing is I'm counting by the fractions of pi. So 3 pi thirds, the same as pi. Okay, so cut pi up. How many equal chunks you need that you step by. That's we need a total of 5. So I got to keep counting. 1, 2, 3. Okay, 4, 5, 6. Isn't it something? If you do it right, 6 pi thirds is exactly 2 pi, which we know that's all the way around. Okay, so 5 pi thirds got me right to terminal edge, what we call this. Okay? So what I like to do once I find the terminal edge is connect every line to the x-axis. Never the y-axis, always the x-axis. Now, as you're doing this, you're probably realizing, pi thirds. I get that it's pi thirds. We're dealing with increments. If we were in degree, we're 60 degrees. So, 60, 120, 240, 100, 360. So it makes sense. All these are steps of 60 or pi thirds. So this reference right here, where we're going to stand, is precisely pi thirds, which is great because they 30, 60, 90. Okay? All right, I start this over here, and then I've got to keep with it. Hold on. So locate that. Now, label it. Step 2, label it appropriately. For math. What I mean by that appropriately is it's in the 4th quadrant. We know that down is negative for y values and right is positive for x values. Okay? Not news to anybody here. You guys have seen that before. So a 60-degree special right triangle is going to be across from the large leg, which is root 3. In quad 4, down. So we got a negative 3. And the short leg, so if that's 60 right here, then 30 is down here. That means I've got a side or a shade of 1. Now, that's going to be positive because that's really to the right, which is my positive value here. So that's 1. And then hypotenuse, till further notice, our hypotenuse is always going to be positive. Until we start to dabble with polar coordinates and pre-calc someday, we're going to stick with a hypotenuse because it's really the distance from the origin out to the end of that point there. So on a 30, 60, 90, 1, root 3, 2, make sure you slap a negative on that value, okay? Now, all you got to do is stand in the corner right here, okay? And do the SOHCAHTOA. So this is a cosine. Go back to my blue pen here. The pen blue. Go adjacent. So here, adjacent of 1. So remember, what SOHCAHTOA tells us adjacent over hypotenuse. So adjacent to hypotenuse of 2. All right. That's the same answer we got using the unit circle. Now, I know it took a little bit of scribbling here. I didn't write step 3 down real quick. I'm just going to say SOHCAHTOA. You label the appropriate trying in the appropriate you're stand and do the SOHCAHTOA. All right, and then the sign, we've already got it built here, so all I got to do is recognize that the sign is going to be the opposite over hypotenuse. Well, in there, that's opposite is going to be negative root 3. Again, we get the sign page 1 of these notes. Negative root 3 over 2. Okay? So I think this is a pretty easy method because I don't have to memorize that much. Just my 2 special right triangles and then remembering where things are positive and negative. The skill of counting by fractions of pi is helpful, but you get better at that with practice. So really, either of these methods are great. I'm not going to be picky about it. This video is getting a little long, so I'm going to stop it right here. But you try doing these 2 for extra practice. It's on page 4. You could pause the video here and try that. All right. I hope you guys are doing great and stay strong.